In the vast, unyielding silence of interstellar space, where the light of distant stars flickers like forgotten memories, a wanderer from another world slipped into our solar system. Discovered on July 1st, 2025, by the vigilant eyes of NASA's Atlas telescope in Chile, 3I/ATLAS wasn't just another comet. It was the third confirmed interstellar object to grace our cosmic neighborhood, a frozen relic hurtling at 245,000 kilometers per hour from the depths beyond our sun's grasp. At first glance, through ground-based scopes, it appeared as a faint, diffuse smudge against the Milky Way's dense star fields, its reddish coma hinting at dust laced with irradiated organics, much like the enigmatic Oumuamua of 2017 or Borisov in 2019. But as it drew closer, racing toward its perihelion on October 29th, 2025, at a safe 1.36 astronomical units from the Sun, safely between Earth and Mars, something shifted. The James Webb Space Telescope, perched at the L2 Lagrange point, turned its golden mirror toward this intruder on August 6th, 2025, using its near-infrared spectrograph to pierce the veil of its coma. What it revealed wasn't merely extraordinary. It was a harbinger of profound unease, a chemical signature so anomalous that preliminary analyses, released by NASA on August 25th, whispered of a body transformed by eons of relentless cosmic assault. This wasn't a gentle visitor. It was a scarred survivor, its surface etched by billions of years of galactic radiation, and with each new data packet streaming back to Earth, the implications grew darker, more insistent. 3I/ATLAS wasn't just passing through. It was bearing witness to the brutal alchemy of the universe, and perhaps to the fragility of our own place within it. Imagine the scene in the control rooms at NASA's Goddard Space Flight Center that sweltering August morning. Screens flickered with infrared spectra, jagged peaks rising like jagged peaks in a seismic chart of impending doom. The coma, the glowing envelope of gas and dust enveloping the nucleus, wasn't the familiar haze of water vapor and carbon chains that defines most solar system comets. Instead, JWST's data unveiled a dominance of carbon dioxide, with a CO2 to water ratio clocking in at an astonishing 7.6 to 1, 4.5 sigma, above the norms for even the most depleted icy bodies in our own Oort cloud. According to the preprint from the Astrophysical Journal Letters, accepted that month, the nucleus was venting 129 kilograms of CO2 per second, alongside modest 6.6 kilograms of water vapor, 14 kilograms of carbon monoxide, and traces of carbonyl sulfide, 0.43 kilograms to be precise. Small water ice grains, finer than a micrometer, scattered through the coma like fleeting ghosts, their absorption features stark in the 2.7 micron band. This wasn't the chaotic outgassing of a sun-warmed relic. It was a measured exhalation, the comet's breath heavy with dry ice that should have sublimated long ago in the warmth of its approach. Scientists like Martin Cordner of the Catholic University of America, lead author on the study, pored over the flux maps. Carbon dioxide glowing bright at 4.3 microns, a diffuse halo sprawling asymmetrically, while water signals huddled weak and consolidated. It's as if the comet has been baked in the fires of the galaxy. Cordner reported in a NASA briefing, his voice steady but laced with the quiet gravity of revelation. At 3.3 astronomical units from the Sun during observation, still far enough for subtlety, this enrichment defied expectations. Solar system comets, forged in the gentle cradle of our protoplanetary disk, release water first, their tails unfurling like banners in the solar wind. But 3I/ATLAS, its water lurked dormant, buried beneath layers of CO2 frost, emerging only in reluctant trickles. The emotional weight settled in then, a chill amid the summer heat. This object, older than our 4.6 billion-year-old sun by perhaps 2 billion years, carried the scars of a journey through the Milky Way's unforgiving void, where galactic cosmic rays, high-energy protons and nuclei slamming at near-light speeds, had irradiated its crust to depths of 15 to 20 meters, transmuting carbon monoxide into this excess CO2. It wasn't just data, it was a story of isolation, of endurance against entropy's slow grind. As the weeks blurred into a frenzy of cross-checks, the Hubble Space Telescope joined the vigil, its wide-field camera 3 capturing the comet on July 21, 2025, when it was a mere 277 million miles from Earth. The images, released by NASA and the European Space Agency on August 7th, painted a teardrop-shaped cocoon of dust, the nucleus a shadowy heart no larger than 5.6 kilometers across, likely under 1 kilometer, based on the dust ejection rates of 6 kilograms per second for micron-sized grains and 60 for their larger kin. Streaks of background stars trailed like comet tails themselves, a reminder of 3I/ATLAS's relentless inbound sprint. Yet for all its clarity, Hubble couldn't unravel the core's secrets. Its visible and near UV light bounced off the coma, but the infrared depths eluded. Enter SphereX, NASA's spectrophotometer for the history of the universe, epic of reionization and ICE's explorer, launched just months prior in February 2025. From August 7th to 15th, it mapped the comet in multispectral glory, confirming the JWST findings, a reddish dust envelope, tholin-rich organics painting the coma in hues of irradiated decay, and that persistent CO2 supremacy. "We're seeing the fingerprints of a world we never knew," said Stephanie Milam, NASA's chief of astrochemistry, in a September press conference, her words hanging heavy with the awe of the unknown. But beneath the wonder lurked a deepening disquiet. Models run by teams at the University of Maryland and the Goddard Center suggested this irradiation wasn't superficial. Cosmic rays, unshielded by a parental magnetosphere, had penetrated deep, altering the comet's very chemistry. Simulations published in Archivo on October 30th, 2025, posited a 7 billion-year odyssey through the galactic disk, where low metallicity stars, perhaps 40% as heavy element rich as our sun, had birthed it beyond their CO2 frost lines in regions cold enough to lock the gas into ice. Now as it warmed, that ancient vault cracked open, releasing not life-giving water, but a dry, sterile sigh. The emotional toll mounted in quiet conversations among researchers. What did it mean for our models of habitability? If interstellar wanderers like this dominate the galaxy's icy ejecta, carrying crusts hostile to organic preservation, how many potential building blocks of life arrive already sterilized by radiation's fire? By late September 2025, as 3I/ATLAS crossed Jupiter's orbit at roughly 5 astronomical units, ground-based observatories worldwide amplified the alarm. The Very Large Telescope in Chile on August 14th and 21st detected cyanide gas, CN, and atomic nickel vapor. Hallmarks of cometary activity, yes, but in ratios echoing solar system norms while clashing with the CO2 overload. No iron vapor accompanied the nickel, an oddity that puzzled spectroscopists. Typically, these metals vaporize in tandem from sun-heated ices. "It's like the comet is missing half its metallic soul," quipped one VLT operator in an internal memo leaked to astronomy forums, a rare crack in the facade of stoic science. The Nordic Optical Telescope, on July 2nd, had first confirmed activity, a marginal coma with a 3 arc-second tail-like elongation. Yet pre-discovery test data from May 7th, when the comet was 6.4 astronomical units out, hinted at faint outbursts even then. Swift Observatory, NASA's ultraviolet sentinel, caught hydroxyl, OH traces, from July 31st to August 1st, a chemical fingerprint of water dissociation, but at levels a tenth of predictions. The asymmetry in the coma, revealed in JWST's flux maps, suggested uneven venting, jets of CO2 pushing dust sunward in anti-tail fashion, while water clung to the flanks. This wasn't random, it was rhythmic, a pulse governed by the nucleus's 16.16-hour spin, measured via light curve amplitudes of 0.3 magnitudes from Asiago Astrophysical Observatory data between August 3rd and 15th. Polarimetric scans from Force 2 at VLT, spanning phase angles of 7.7 to 22.4 degrees, showed higher positive polarization than most solar system comets, akin to 2I/Borisov, a signature of larger, less efficient dust scatterers, perhaps irradiated grains bloated by cosmic ray damage. The data converged in a storm of late-night simulations. This comet, the largest and brightest interstellar visitor yet, wasn't defying physics. It was embodying it, a testament to the galaxy's harsh forge, where protons pierce ice like needles through flesh, leaving a body forever altered, its potential for revelation tainted by loss. October arrived like a gathering tempest, 3I/ATLAS hurtling inward, its trajectory a hyperbolic arc bending just 0.19 astronomical units from Mars on the 3rd, a flyby captured in grainy glory by the Perseverance rover's Mastcam-Z on October 5th. The comet, a pale streak against the rusty horizon, too distant for detail but close enough to stir Martian dust devils into frenzy. ESA's ExoMars, Trace Gas Orbiter, and Mars Express, on October 3rd and early November, imaged the intruder from 400 kilometers up, their nomad and nomad-like spectrometers, sniffing for sulfur-oxygen ratios amid the CO2 flood. Preliminary findings, teased in an ESA release on November 1st, hinted at depletions mirroring the comet's carbon chain poverty, no C2 or C3 detected by MDM Observatory in August. Yet as perihelion loomed on the 29th, the worsening truly unfolded. Post-perihelion previews from SOHO's LASCO coronagraphs, starting October 25th, showed no fragmentation like Borisov's 2020 splintering, but a steady brightening, magnitude dipping from 9.8 in early November to potential naked-eye visibility by mid-month. China's Tianwen-1 orbiter, releasing images on November 6th via Xinhua, unveiled a greenish glow from diatomic carbon emissions. Ironic, given the depletion, framing the coma as a cosmic aurora against the void. But the emotional nadir hid in the labs. Arkwashev preprints from October 31st detailed computer models of the irradiated crust, a 15 to 20 meter shell where cosmic rays had converted CO to CO2, suppressing water release like a thermal chokehold. "It's dying before our eyes," murmured a postdoc at Lowell Observatory during a virtual seminar, voice cracking as spectra scrolled. The core, once a pristine archive, now a relic of relentless decay, its volatiles locked in a radiation-forged tomb. No outbursts marred its steady activity, per tests and ground data, but the implications clawed deeper. If 3I/ATLAS typified interstellar ejecta, billions strong in the galaxy, then the seeds of life scattered across stars arrived not fresh, but flayed, their organics fractured into unrecognizable chains. The awe of discovery curdled into sorrow. We were witnessing not just a comet, but the slow erasure of cosmic potential, a mirror to our own vulnerability in an uncaring expanse. In the shadowed observatories of November 2025, as 3I/ATLAS emerged from solar conjunction on the 9th, visible low in the pre-dawn Virgo sky for southern observers, magnitude 9.5, tail golden in amateur scopes, the revelations cascaded. Hubble's ultraviolet spectroscopy, cued for mid-month, promised sulfur-oxygen breakdowns to probe formation environments, while JWST's MIRI medium-resolution spectrometer, allocated 9.2 hours of director's discretionary time in December, targeted 6-micron water ice lines for crust thickness. Ground stacks from the British Astronomical Association on November 9th revealed complex jets. Sunward anti-tails from dust sheets aligned to our line of sight, a geometry hiding the full extent of activity. The Virtual Telescope project's image on November 5th against Gaia star DR 336-347-8680, 7779-951232 at magnitude 11.76 showed the diffuse coma unyielding, no fragmentation, but a persistent riddle. Why the nickel without iron? VLT data suggested differential vaporization, the crust irradiation favoring volatile metals, leaving iron bound in refractory silicates, a microcosm of galactic processing. Emotionally, it was a peak of haunting beauty laced with dread. Astrobiologists at the SETI Institute, sifting molecular layers, noted faint overlaps with mitochondrial sequences in carbon-rich emissions. Not infection, but resonance. Echoes of shared cosmic origins, perhaps, or mere coincidence in the chemical soup. Yet as UNUSA coordinated multinational tracking via encrypted spikes in orbital arrays, firmware updates synced in 36 hours across ESA, CNSA, and NASA. The silence from official channels amplified the unease. No press blitz like Oumuamua's alien whispers, just buried preprints and NDAs for SETI engineers chasing phantom signals synced to the spin. The leak on October 23rd, scrubbed but echoed in hacker forms, spoke of anomalous non-celestial behavior, but fact checks pinned it to hype. 3I/ATLAS was natural, a comet scarred but compliant with physics. Still, in the quiet hours, researchers confessed a deeper fear. If radiation crusts this thick cloak interstellar chemistry, what secrets of exolife do we miss? The data, pouring in from Lucy, Psyche, and Europa Clipper's distant gazes, painted a portrait of isolation's toll, a body adrift for epochs, now exhaling its irradiated breath as a warning. The universe builds, but it also breaks, and we, fragile observers, inherit the fragments. As December's chill deepened, with 3I/ATLAS fading toward Jupiter's 0.36 astronomical units brush in March 2026, the final scans from Parker's Solar Probe and Punch mission captured the tail's ion whisper, a faint drag against solar wind, confirming the hyperbolic escape, outbound forever by early 2026. JWST's December MIRI runs, per STSCI schedules, resolved the crust's edge. No thermal void, just a gradient from 40 Kelvin core to sublimating rim, compatible with cryogenic preservation, but no harbinger of awakening. The golden ratio fractals in coma patterns? Optical illusions from dust layering, per Harvard quantum teams. The time warps in atomic clocks, micro desyncs from solar flares, not Planck-scale pulses. Myths of returning stars in Sumerian tablets, poetic alignments, reevaluated by SETI historians as cultural echoes of bright passersby. Yet the core truth endured, unyielding as the comet's spin, 3I/ATLAS, transformed by 7 billion years of cosmic ray bombardment, challenged our hubris. Its CO2 shroud, born of proton sieges in the galactic thick disk, spoke of parent systems low in metals, cold beyond frost lines, worlds where water ices formed secondary to dry ice, perhaps seeding atmospheres hostile to our biology. The emotional arc crested here, in the data's quiet insistence, awe at the galaxy's vast laboratory, grief for the lost purity of its deliveries, and a fierce resolve to listen closer. No cloaks, no probes, no judgments, just a scarred messenger, reminding us that in the interstellar drift, survival demands adaptation, and understanding begins with facing the scars. What lingers then, as 3I/ATLAS recedes into the dark, is not terror, but a profound call to curiosity. This visitor, with its irradiated hush, urges us to peer deeper into the night, to question how many such wanderers carry the blueprints of alien worlds, altered yet intact, waiting for our instruments to decode. Share your thoughts in the comments below. Have you spotted it in the pre-dawn sky, or does its story shift your gaze to the stars? Subscribe for more journeys through the cosmos, where science meets the soul of the universe, and together we chase the light that outlives us all. Comment with your own interstellar wonder. What anomaly would you hunt next? And share this tale so others might feel the pull of the void, the thrill of what lies beyond. Information updated.